Hello everybody, I'm Larry Marlowe of Professor Lindenberg's 116 Technical Writing class. Today in this video we are here to talk about the career path we are choosing to go down and also the analytical report we're going to write and a little bit of information on that analytical report, why we chose to write it, what the hypothesis is of this report we're going to write, and also how far we have come on this report. So to tell you a little bit about myself, I'm going for a combination chemistry material science type of field. I have my associate's degree in material science metallurgy, and I'm trying to achieve my bachelor's degree in chemical engineering. And I'm doing this kind of as well. The main fact is I do not know any places locally that actually offer a bachelor's in metallurgy. So I'm kind of doing a chemical engineering degree so I can basically get a position as a metallurgist, and I can also broaden my skills with the basic knowledge of chemistry, and also the fact that if I do not want to continue this job, I can go into chemistry as besides just some type of material science work. But my main focus on getting the degree is so that I can become a metallurgist. And my project actually ties into some of my prior academic work. I had a class in my material science program that was Metallurgy 280, and that is basically where we had to come up with our own metallurgical experiment, and for the 15 weeks of class we were able to kind of conduct this experiment, gain all the data that we needed, and we had to come up with a conclusion. We had to basically do as we're being told now. We have to come up with our own hypothesis and then kind of formulate a conclusion off of it. And at the end of this class, Schoolcraft have to put together a little presentation in the Vista Tech Center. We were actually gone there, and the culinary art department actually cooked up dinner, and we were presenting our presentations to family members, a panel of people within the field that our teacher knows. So we kind of had to present in front of people that knew what we were talking about, and also just kind of give out our reports to these people to show our skills in this field, what we've learned so far. So it's kind of like a master thesis, but in a sense of an associate's program. So it was really nice, and from that I gained a report that I actually accomplished within this program. But now I feel like I can one up this report. I feel like I can make it a little bit better now with more metallurgical knowledge, and also the fact that I am in technical writing right now. I thought I could spice this up. This presentation is something that I use all the time when I interview with different companies in the metallurgical field. Right now I'm a lab technician, a material science lab technician. So when I got this job, I actually used this piece of material to show the boss what I was capable of and a little bit about myself through this. And the hypothesis I chose in that class was the effects of prior mechanical and thermal deformation to the formability of A36 hot rolled steel, which really breaks down to giving it some type of process that induces stress prior to what this material is going to see in the working field. So basically what we're going to do is for one process, I had three different types of processes. One was a drill, one was a blanking process, basically a type of shearing style, and also a plasma cutting. And what we would do is we would create a hole within a coupon of metal, and basically after we were done creating this deformation, this load, I guess you could say, it was then stressed. We were elongating the piece of material in a tensile stressing machine to certain percents. So then after those certain percents of elongation, basically stresses that we induced on the material, we would actually see how those deformation processes that we prior did to the stressing of the material, how they would act, which one would crack the most, which one would fatigue the most, which one was a better process if you were doing something that would put a lot of stress into the material. So basically we were trying to test out different theories and how good of a process you want it to be. I mean, if it's just something rough, it would show you that you could choose one of the other. I mean, maybe one's a little bit more cost efficient. This kind of just was something we put together to show our skills in the metallurgy field, which this did. I mean, I got to use a scanning electron microscope, which would actually show me how the material fatigued and how it broke apart. Basically, was it a brittle fracture? Was it a ductile fracture? And from this, I could put together a load of information to document which process would be better to prior stress and deformation. And basically, from this, I'm taking all the knowledge that I've gained after the fact of my school and all the work experience, and I'm actually gonna put a little more effort into this and kind of give myself another working piece to present to the people that I interview with, and also to kind of give them a little bit more professional. Now that I'm out of the field, or out of the degree, they know that I should have gained a little bit more knowledge, and now I will be able to have the professor grade this not only on a scientific metallurgy standpoint, but I'm going to be able to get this graded on a writing standpoint, which I will use in my benefit to kind of like I said, make it a little bit more professional. And I hope everybody else's project's going well. Thank you.